Um, yeah, so that's task force report on CO2 utilization and negative emissions technology, which came out in 2016 near the end of the Obama administration. Of the 5 main recommendations, number 2, harnessing the natural biological carbon cycle is the one most relevant for us. And of the recommendation under number 2, we highlight those related to optimizing crops and management technology that stabilize organic carbon. So these 2 documents were key inputs to the Biden climate plan. Here's a screenshot of the plan from Biden's campaign website. And here again, we're highlighting just a couple of focus areas of the plan: decarbonizing the food and agriculture sector and climate-friendly farming. And finally, the Biden climate plan supports the UN Sustainable Development Goals. And of particular interest to us, SDG 2, zero hunger. Each SDG has several tasks, and of particular interest for us is 2.4, which is ensure sustainable food production systems and implement resilient agricultural practices. And that's associated with each task is or are indicators or metrics. So for task 2.4, the particular indicator is the proportion of agricultural area under productive and sustainable agriculture. So that, as I said, indicates with a very high level description of the Biden climate plan and 3 related documents just to set up the framework for the subsequent talks. Now I'm going to just recapitulate all that graphically in a quote unquote seed concept map. Now, and you can get to this link also under the resources for this session in the notes page. So everything shown in this concept map should look familiar, right? So here are the 4 documents: the Climate 21 Task Force Report, Biden Climate Plan, and SDG Goal number 2. And here are the 2 recommendations, which are input to the Biden Climate Plan, which has a focus here and supports the SDG. Okay, it's a graphical way of representing everything I just mentioned. So we call this a seed concept map because as each of the speakers coming up present their material, we'll be adding to this seed map. And you can follow along by viewing the live version of this map, the link to which is also under the resources for this session in the notes page. And after all 3 speakers are done, Brian will present the kind of the final version of the concept map with all the 3 speakers' materials incorporated, and then give everyone instructions as to what we would like you to work on in the breakout groups, which will come up at around the 60-minute mark of this session. Okay, so now it's my great pleasure to introduce our first speaker, Todd Walter. Let me see. Hey, Brian, I can't see the. Is Todd on the?
He does not appear to
not yet?
be. Yeah, not yet.
Okay, shall we then go to Steele then first?
Uh-huh.
Okay, so a great pleasure to introduce our first speaker, Steele Lawrence. Steele is the head of sustainable business of the Farmers Business Network, FBN, and he'll be presenting on environmental traceability in the agricultural supply chain. So I'm gonna unshare here. Find stop sharing. Yeah, if you can share and then start, I'm gonna hand off to you.
Sure. 1 second. Let's see. I'm having some problems here. It wants me to allow in my system preferences. Ooh. Which I would have to quit Zoom to be able to do. Maybe we can pass the bar and come back to me.
Or we could drive the slides for you.
That would be fine as well.
Bill, could you do that? I will continue.
Yeah, let me see.
Or if well, I can do that also. I have it up ready to go. So should I?
Either way, I have the PDF, so I can do that.
Okay.
Hold on.
And by the way, Todd is back. I mean, Todd is here.
Oh, is there? So shall we?
Yeah.
Shall we go back, follow the, or shall we just go ahead? It doesn't really matter too much, right, the sequence.
Yeah.
Yeah, so let's do still, give
Okay.
Todd a breather here.
Okay.
Yeah, happy to jump in. Thanks for having me. So as Bill and Brian have said, my name is Steve Lorenz. I'm head of sustainable business at Farmers Business Network. I'm also a head of sustainable business at Gradable, which is a sister company primarily focused on scoring environmental attributes for growers and helping them flow that information on to buyers and markets who fundamentally want to buy more sustainable grain. So you can hit the next slide. So FBN got its start 7 years ago as an agronomic technology platform that allowed growers to share what is a tremendous amount of information that's produced at the farm level with each other to benchmark and see for specific soil types, for particular farming practices, how they benchmark against each other in terms of performance. And that performance, while in the past has largely focused on yield, for us, we primarily focus on return on investment. So what may be a yield beating practice or genetics of seed that you plant may not actually result in the highest ROI depending on input cost. So the slide that you're looking at here is a visual representation of our network. Today we have approximately 20,000 members representing 60 million acres across the US and Canada in more than 44 states in the US. And then we have recently added Australia to our network as well. The analytics and the acres are primarily corn and beans, approximately 60 to 70%. The rest is a smattering of commodity and specialty crops, rice, sorghum, wheat, relatively de minimis in terms of tree crops or other produce. And you know, that kind of makes sense as you see our geographical footprint. You can go to the next slide. Yeah, and you can skip past that as well. So our business, we started as an agronomic platform that allowed growers to share that information. That's still core to what we do. But as of last September, we have made that platform free to any grower so they can come in, share information and see what the results look like and start to plan anywhere from optimizing of seed and genetics through to nitrogen application and various other agronomic decisions that they have to make. What our business now is best represented as is two commercial units. On the input side, we are the largest e-commerce retailer in the US, and most of that business is crop protection and seed, both branded and generics. And then on the other side of the business, we run what's called our crop marketing and financial services business, which really helps growers with marketing decisions and risk management. We have a merchandising desk, meaning that we actually buy from growers and then package and resell. We're a licensed crop insurance provider. We have a finance arm that finances land, equipment, and operating loans. We have a risk management business that advises growers on when and how to market on their own. And then we have my business, which is the sustainable term sustainable business, which is focused on helping growers find preferential market treatment and premiums through providing transparency and further practice adoption of regenerative practices and soil healthy soil production focuses. So you can skip ahead to the next slide. So what we're really working to do is use this data and this infrastructure to be able to connect growers to supply chains and buyers who care about reducing the environmental impact, primarily measured in carbon intensity of their inputs. So said in plain English, box of pasta sits on the shelf. We can provide the traceability and the environmental scoring to help you understand, help a consumer understand exactly what the carbon intensity is of the wheat that ended up in that product. That is really important as we look at the various ways that grain flows through and into final products, but essentially three main categories where that's important: biofuels, animal feed, and food grade. You can go to the next slide. Yes, so there are a couple of challenges with that. The first is that buyers as they exist today really can't source environmentally friendly grains and have the transparency to be able to see that. And so what we can do through the agronomic platform that we have is provide this information to growers in a way that protects, provide this information into buyers in a way that protects individual growers from having all of their practices revealed, primarily things that are highly sensitive, which are inputs and yield outcomes. That's about as close to IP as a grower will have. The second component is that consumers are demanding, so end consumers are demanding this kind of transparency, but actually aligning the supply chain to be able to do that is very difficult. And so what we can provide through our various structures, not only the environmental scoring component at the field level, but also buyer technology that we have, and the merchandising capabilities that we have. So the ability to provide incentives to growers based on hitting certain environmental scores, a certain carbon intensity score, for example, in the biofuel space, we can provide premiums and incentivize those programs with that level of technology that we have. Finally, companies are looking to reduce their upstream emissions permanently. And so this is a kind of a being addressed in two ways, both in the offset market today, which there is a lot of excitement around, but also in inset markets, which is essentially instead of buying a carbon credit from a source that is not directly involved with what you do in your supply chain, we can instead help you to buy and retire credits from growers that you actually work with that flow information and grains into the processors that you work with. So being able to do all of that is I think really only empowered by technology that has been recently developed. Can you hit the next slide? So there's three components that folks should be aware of when you're working in agriculture supply chains to be able to reduce climate impact. And the first is that incentivization for growers is critically important. There are lots of discussions about, do regenerative soil practices like cover crops and tillage, reduction of tillage, makes sense for growers to adopt on their own, return on investment merits based on improvements in soil health? And the answer I can tell you definitively is no. Growers need to have additional cost sharing and incentivization programs to make the adoption of those practices palatable, both from an investment standpoint, but also from a financial investment standpoint, but also from a education standpoint. These are not easily practices to implement and require extensive training and education and experimentation on the grower's behalf. And so the mild ROI that may be available for some growers in certain conditions is not enough to be as widespread as growers need to be. The second component is an element of verification. I can't stress how important this is. So I think that there are two schools of thought here. Reduce the amount of verification and certainty that we have in the field as much as possible to limit the time and effort that growers have to spend on it. And the second school of thought that I come from and FBN comes from is work within the data structures that already exist. And so growers don't have to fill out a bunch of different forms, but get as detailed as you need to be to build highly certain crediting systems in to these programs. And so being able to have that verifiable supply chain and all the way back to the farm level with all of the data that we have is crucial to retaining value in that system. And then finally, we can establish really, as buyers have unique goals, not just in carbon, but also in water quality and water quantity, in biodiversity. All of that is possible with the core framework of the 2 points listed above. With incentivization, with having that verifiable supply chain, there is really no limit of boutique programs that can be stood up to make various claims to end users. Can you get the next slide? So this is a little bit about how we work. To run a specific program, we will recruit growers to participate in that program, both sell grain into that supply chain if they aren't already, and then also to provide the information required to show that they're hitting certain environmental goals, whether that be based on where they are today or whether they're making improvements over time. We then plug in that data and provide environmental scoring. Farm data, for those of you that have ever worked with it, is messy. Some comes very neatly from modern farming equipment, from John Deere, from Case, but much has to be collected in other means. And FBN runs a data operations team that ingests everything from pictures of commercial receipts to written records to make sure that data gets where it needs to go. Then we do carbon intensity scoring and environmental scoring. FBN does not build its own environmental models. We use third-party models. We've used GREET, Comet Farm, Field to Market is a flavor of some of those different models. We've also used N-Balance, which is a nitrogen use efficiency scoring produced by the Environmental Defense Fund. Tracking and validation, which I would expect that much of the interest is on today's call, is largely done by us in 2 ways. First is that we layer in third-party information that comes in the form of weather information, satellite imagery. It also comes from USDA data and soil sample information. And then we build a picture that triangulates claims that back up and add credibility to claims that growers are making at the field level. And then we also, given the size of our network, are able to produce our own credibility score. Essentially, given that we know the claims that those growers have made, we can compare the input claims, the weather, the soil types, and then the observed output, essentially the yield, across millions of other acres who saw similar events, and then build statistical models that evaluate how likely those claims were to actually be accurate. So we have not found much really gaming of any system at all. It's much more about the finding mistakes or misreported data by accident and going back and correcting that. And finally, FBN does quite a bit in processor partnerships. As I've said previously, grain supply chains are complex. You have buyers, aggregators, processors, sometimes several different processors, and then you have end brands and retailers who end up marketing to customers. So to be able to tell a cohesive story across that is crucially important to be able to make claims to end consumers. Can you hit the next slide? So this is an example of what we have done in food. Solutions for food. And I'll be brief. I know I'm running up on time. FBN Analytics work across all farms or many farms at a field and subfield level. We track that grain to a mill, a delivery point, and then we provide, depending on the requirement, either a mass balance scoring for that whole facility that then they can go market on it, or if they're doing really a true identity preserved system, we can monitor that and flow that information along to the CPG, the brand, and then we can make exact carbon claims on package for how much carbon was consumed in that product, and that does require additional information from both the the mill and the consumer packaged good brand, but largely for the products that we work in, somewhere between 50 and 70% of the total carbon intensity of that finished product is driven from the feedstock, from the agricultural input itself. Next slide. And I'll end here. I may have one slide after this, but this is a really important information on what the opportunity is for decarbonization in agriculture. What you're looking at is a graph that measures the carbon intensity of corn feedstock for a ethanol plant in South Dakota. The red line, that the individual blue lines are how carbon intensive each farm was production of corn. The red line is the national average, which is how how biorefineries are credited today. And the green line is the actual average for their supply chain. So the reason why it's important to be able to measure the carbon intensity for growers at the farm level is because in the example of biofuels, when you're selling into regulatory markets that provide credits back for beating certain carbon intensity standards, in fact, there is quite a bit of opportunity to both show where actuals are today for given supply chains. But then also, if you look at the immense variation that happens in between farms, you can see that it's really important to be able to provide incentives to individual farmers to improve practices, because these growers are all neighbors. If we were to give them a regional estimation of how energy efficient they are, in fact, you would be undercrediting many and overcrediting some. But if we can provide solutions that incentivize individual farmers, all of these growers, or none of these growers, were optimized today in terms of carbon practices. And all of these growers are operating under certain similar circumstances, which suggests that they can substantially improve, and that, for example, the growers that are 50% over the national average, in fact, could likely look very similar to their neighbors who are scoring 30, 40, even 50% below the national average. Can you hit the next slide? Great, and this is just an example of how the solutions work for fuel. So low carbon grain flows into an ethanol producer, in this case, Poet. That group can then market lower carbon biofuels to a market that cares, particularly the LCFS market in California, which is the largest clean fuel program in, I believe, the world. And that ends up being very valuable to that group. They can flow those credits back in incentivizations to growers to continue to share that information and to continue to drive down their carbon intensity. As Bill mentioned earlier in this presentation, he highlighted a lot of the new Biden administration's plan to decarbonize ag and food systems. But this is a really unique intersection between food and energy systems, both of which are high priorities for the C21P. So you can hit the next slide. That may be it, actually.
That's the last one.
Okay, great. So I have no idea where I am on time, but happy to take questions if there is time.
Okay, great. Thanks, Theo. That was very, very interesting. Yeah, we can probably take a quick question or two if anybody anything pressing. Otherwise, we can wait until the group discussion at the end.
So Phil, I have a question about your previous slide. What's are those like averages over many years for those CI scores for those farms, or is that just like a given year?
That's a given year.
Okay.
And I take the point of your question as there can be variation over time in individual farms and certainly in fields. Where we are, where we're likely to land there is to take a 3-year average of a grower's individual carbon intensity score. But the information that you looked at there is for 2018, the growing season of 2018.
And was that for a particular state? Because you have a million more dots on your map than there were bars on that graph.
Yes, so that was for a specific supply chain in South Dakota. Yeah, so all of those growers delivered to one ethanol facility in that timeline. And so the project was to build a composite score, an aggregate score for that ethanol producer to show what their carbon intensity score was for their feedstock.
Got it. Beautiful.
Do you see variations in carbon use with climate, as in growing corn in Illinois versus growing corn somewhere that might be a little colder and drier?
Yeah, absolutely. So the score, and maybe you can run back to that slide because I think there might be some discussions here, but this is really a measure of efficiency. So it is about the energy that goes in and the bushels that come out. And there are a lot of factors that go into that are not necessarily malleable for the growers. You're going to have, the lowest amount or the highest amount of nitrogen use efficiency in your I states, Ohio.
Ohio, yeah.
It's been a bit of a day, excuse me. Iowa, Illinois, Indiana,
Sure.
where soils are much more rich. You have certain climate zones, things of that nature. But really there may be, if you start to individuate states or within certain regions of states, you may have natural geographic and climate winners here. But the point is rather to show that everybody can improve the carbon intensity score. And then also potentially, if our goal really is to make sure that crops are grown in the places that are most effective and efficient for them, that a national programs like that are being developed either in a clean fuel policy or in other programs that will reward growers for that may change the path of what is grown where.
Okay.
Thank you.
Great. I think we probably should move on. So if any of you have additional questions, maybe you can put in the chat, and if you have time, willing, maybe you can respond, via that way. So let's move on. So our next speaker is Todd Walter from Cornell University. Let me just first note that originally we had Todd going first, then Seal, then Lindsay, because we were thinking local, regional, and global. So now I guess we'll be regional, and local, and global. So just keep that in mind for whatever that's worth. So Todd Walter from Cornell University, the Department of, he's a professor in the Department of Biological and Environmental Engineering, and he'll be presenting on land management and carbon sequestration. So Todd, I'm going to stop my sharing, and if you, see if it works for you.
All right, am I up?
Okay, great.
Yeah, thanks, Bill. So yeah, I'm kind of more at the local level, but hopefully I can bridge back to what Steele just presented, which is awesome. So I hopefully the connections will be still pretty strong. Yeah, I'm mostly interested in non-point source pollution, but I think Dan Fuka maybe was the person who kind of linked the carbon sequestration and the types of things I study together. So I'm going to hopefully make that work. Zach, are you on the line? Did I see you earlier? I think Zach Easton's here as well. So
I'm watching.
He's a super expert on this stuff as well. So he will tell me where I'm wrong. So let me just start this. But the one place where I really work on carbon sequestration is actually in Alaska, and I look mostly at the Tongass National Forest, which is has billions of tons of carbon sequestered. It has something like maybe 5% of the nation's carbon is actually sequestered in this one sliver of the landscape of our whole country. And just to put that in context, it has as much carbon stored there as the U.S. emits annually. So the point is just simply landscapes have a huge potential to store carbon. And I think this goes back to Steele's points about different management practices, which we'll come and talk to a little bit here in a minute. The Tongass is a great carbon sink because of a couple things. It's super wet. They get over 2 meters of rain a year. Okay, Ithaca is known as being a really wet place. In fact, the Cornell's newspaper is called the Daily Sun, so that they could say the sun comes out every day in Ithaca, even though it rains a lot here. But even with given our wet climate, the Tongass is even more wet than us. It's also well vegetated, right? So you can see in this picture, there's tons of trees. They're sucking carbon out of the atmosphere and they're putting it into the soil. And so they're sequestering it in the biomass and in the soil. It's also cold, which kind of reduces oxidation rates, but there's not much we can do about that. But we focus on those first two, wet areas and being well vegetated as being two ingredients for sequestering carbon. I think that's kind of where I'm going to go with the rest of this talk. Okay, and so if we look at agricultural landscapes, again, we got management, cover crops. Steele talked about those a little bit, and it'd be great to know how prevalent those are. Here in the Northeast, we haven't needed to incentivize too much to have farmers use cover crops. Mostly, they just want to be able to show that they're at the forefront of trying to minimize environmental problems. And then these wet areas here on the right-hand picture here, there's a wet area in a field not too far from Cornell. And knowing where those areas are, it can be really important. And in fact, that's probably where I'm going to focus my presentation a little bit is can we figure out where those areas are and how can we leverage agricultural policies? Okay, so there's the Conservation Reserve Program, I think came out of the 1970s, and then the Conservation Reserve Enhancement Program. And there's another one, and this is where I want Zach to be in here, CREAP, I forget what the A stands for, but these are all conservation programs that have been put forth by the USDA ostensibly for conservation purposes. In reality, they're actually put there to reduce corn yields in order to keep the price of corn high. So even though they're called conservation programs, that's kind of a disingenuous reality. But because they exist, we can actually use these programs to try and figure out how can we use them to actually, well, in the context of this meeting, how can we leverage them to enhance carbon sequestration in the soil? Because, well, we'll talk about it as we go along here. And there's lots of other programs as well, but they're mostly there for price controls, not for conservation. But we can use them because they are on the books. Okay, and so here's a picture, and this goes back to Bill's point. This is a very local picture here. This is a Cornell research farm, actually, and we've mapped out the wet areas in blue and the dry areas in orange and yellow, and we've used tools that several people on this call are familiar with. And my thought, what I want to kind of bring to the table, and this is where I think we could overlap with Steele's talking about. Can we figure out how these areas are distributed in the landscape to target our adoption of CRP or CREP or similar incentives to try and preserve those areas? And that's the areas where we're going to actually be able to store lots of carbon. In truth, these are not the greatest producing areas anyway. So there's already kind of an incentive for farmers to take those out of production if they can have, and this goes back to Steele's point too, if there's some sort of incentive for them to put them into something else. The problem is that they're not, the way they're distributed in the landscape is kind of complicated from a crop management perspective. But anyway, let's not worry about that right now. And where I got interested in these was because these were also the areas generating lots of non-point source pollution. So for me, there's an extra incentive. And I Steele, I keep going back to you. I think there's multiple environmental benefits in some of these policies or practices that we put in place. And so this is another one of those cases where we may get multiple benefits if we target these areas. Okay, and so this is actually the watershed I live in. And I just want to, this is kind of a complicated picture here. One of my former students, named Becky Margeris and Dr. Margeris, and now she said, what if we had average soil moisture conditions and we got an inch of rain on the watershed where Todd lives? Where would that, where would the soils get saturated? And so that's all these blue blobs all over the place. That's what she determined. And she said, well, what if we had the same area, but we just did it in a more formal conservation practice of just simply like looking at an area around a stream, a riparian buffer. And so that's what the pink areas are. And what you can see in this picture is that there's some cases where the blue and pink areas overlap well, but there's a lot of blue blobs that do not align with the pink. And there's a lot of pink that doesn't align with the blue. So the idea is that maybe we should be looking at things not farm by farm, but is there a way we can look at larger, in my case, I look at watersheds, but maybe there's regions. I don't know exactly what the right scale is, but can we protect these in the case of this picture here? Can we protect those blue areas? Let's not have them be in conventional agriculture. Let's not have them being tilled. Let's take those out of production. And maybe that's where we can start to sequester carbon and reduce non-point source pollution. Okay, and I actually live in this top right area here, which is really blue, and so I'm proud to say that we don't have any agriculture on our land. But yeah, we need to think about what scales can we actually think about envisioning new policies. Okay, and this is just kind of a geeky thing for you. So just so you know how we came up with those blue blobs is we use a thing called the topographic wetness index. Okay, and so you take any point in the landscape, that's what this dot is here, and lambda stands for topographic wetness index, and you just look at like how much land is above that, what's the local slope, and then this T parameter has to do with soils. Okay. The only point in showing this is not that you actually want to go make these calculations yourself, but that these data are publicly available. They're available across the entire United States. And in this particular picture, this is a watershed in the Catskills. The dark areas are areas that are going to be relatively wetter than the light areas. So this gives us a way of like kind of prioritizing what parts of the landscape we might want to protect. And maybe enhance our ability to sequester carbon. Okay, and this is this again is just to kind of show some data. And what we have here is on the y-axis. This is essentially how wet the soil is. Okay, and each one of these boxes is a site and time when we actually went out, and when I say we, I mean Brian Buchanan and Margaret Fleming, who are the first two authors on this paper, went out and measured soil moisture. And on the x-axis is that index I just showed you from that previous slide. And you can see and these little blue numbers here, these are the R-squared values. So you can see with data that are just regular, super available, we can get a pretty good sense of where the wet and dry areas in the landscape are. Okay, and this last, and I just want to also mention Katie Hoffmeister extended this data set in 2019. And so we have several more years of this, but it all shows up being the same. And we can play tricks to make the fits be even better, but let's not worry about that. This is a paper, again, Zach and Dan, who are both on the call, I think, participated in this. This isn't exactly the same thing, but this just kind of shows how we can take these readily available data and know something about soil moisture, runoff potential, different parameters that are probably directly related to sequestering carbon, and we can actually scale. These things don't have to be necessarily super localized at a field or watershed scale. They can be, in this case here, these guys did an awesome job of extrapolating this type of analysis over the entire continental United States. So the take-home messages I think I have from this are land management and targeting the right parts of the landscape are a super great way to try and enhance carbon sequestration. We have the computational tools that are necessary to evaluate and sort of plan such strategies. And there are already policy tools in place that we can take advantage of to push this forward, even though that's not what they were necessarily planned for. So with that, I will stop because I don't want to go too long, and I will answer any questions if anybody has them. I don't know, Bill, did I go long?
Oh, that's fine. Just right. Thanks. Yeah, very, very interesting. We have time for a couple of quick questions.
Awesome.
So Todd, just a quick one. So in the local area around Ithaca or Finger Lakes, right? Are you working with, farmers there on these?
Oh, absolutely.
Approaches?
Yeah, sort of a philosophy. And again, I will just point out Zach and Dan are both on here. We've always had a philosophy of working as much as we can on real working farms in the region, just so that we're not deluding ourselves and believing that a research site, a research farm is actually representative of a real farm.
Right. Great. Anyone else with a question right now? Or
So Todd, if you were thinking about policy, and obviously the very local, it appears to be very influential on how a policy decision at the federal level, how beneficial it is. What would you suggest to the policy makers so that they don't make the wrong decision, like just saying stream buffers versus looking for areas within the watershed, when this is obviously something that covers the entire continental U.S. And all agricultural areas?
Yeah, so I think there's an educational standpoint. Part of that, Dan, is letting people know that riparian areas aren't necessarily the most important parts of the landscape. I mean, I don't want to discredit them, but I think there's other ways to evaluate where the important areas are. This is where I think some of the data that Steele is collecting could be super interesting. Where are farmers getting their information? How are decisions being made? And he mentioned that incentives were really important. And when I looked at his footprint, I could imagine that in the Midwest, that's probably really true. But farmers don't get their information from policymakers mostly. I think they mostly get it from whoever's selling them the fertilizer, whoever is contributing to their industry. So maybe that's where we need to kind of engage with. I don't want to use the word education because it sounds like I'm saying people aren't educated, but maybe that's where we need to be dropping in information to get it as widely dispersed as possible. And again, going back to Steele's data, it'd be interesting if we could leverage the type of information he's collecting to figure out how farmers are communicating with other entities to come up with the information they use to make their decisions.
And I have one follow-up question. We went from the top down there. How would you use this to, what would you recommend for protecting the farmer? Because you are showing things that now policy builders can actually do that actually go to their individual properties.
Yeah, so that's a good point, Dan. And I think what we're trying to do here in New York State is work with the DEC to provide what essentially is get out of jail free cards. If you're taking this information into mind and developing management strategies using what we're saying is the best information available, if an accident happens, you have a get out of jail free card because you tried to do the best things possible. I don't know how to do that. And you were part of that paper, and you and Zach were part of that paper that looked over the whole United States, right? Conditions change from region to region. So I don't know how this thing chunks out into small units, but the degree to which we can help policymakers and farmers, again, we're looking at ag land only, have some way of working together and not being adversarial. I don't know if that made sense, but that's as good as I can do right now.
Very good. Yeah, so let's, I think we better move on. Thanks, Todd. Very, very interesting. Our last speaker, not the least, is Lindsay Barbieri. She goes by Bar, who's a PhD candidate at the University of Vermont. And she'll be presenting on the UN Sustainable Development Goals and the connection to agricultural data. So Bar, do you want to share your screen?
Yes, first let me unmute. Can you hear me okay? Yes. Okay, yes. And then let's see. Oops. Oh, I have so many R windows open right now. Hold 1 second. I'm in the depths of data analysis currently, so I think I am now sharing it. You all see my presentation?
Yes.
Okay, wonderful. Thank you. So hello, everybody. So I'm Lindsay Barbieri, as Bill mentioned, PhD candidate in natural resources and ecological economics at the University of Vermont. And I've been spending a lot of time sort of thinking about different facets of agricultural data collection, semantic linking, and the UN Sustainable Development Goals. A lot of the work that I'm sort of showcasing here, presenting on here, is kind of launched from work that was showcased at the International Data Week in 2018 by a variety of folks, of which you will perhaps know some of them. Pierre Luigi in particular, I know, has a lot of involvement with ESIP and the semantic cluster here. But yeah, so let's just dive right in. So just to kind of situate where I'm thinking at right now is, a lot on the one hand of sort of data, information, and technology, and this idea of accelerating data generation and technological change, and then how that sort of intersects and informs and could help respond to accelerating environmental degradation and sort of these global goals of resource use and social inequalities. And from that perspective, the UN Sustainable Development Goals is one sort of framework that is that's useful for having these different goals to address these, these specific targets, both environmental and social targets. So situating my own research a little bit more, I'm actually, it's funny to think about myself as the global context, because actually a lot of my agricultural research is field-based and local in Vermont. But I have been, thinking a lot about how to scale between these different scales. So my own work is looking at agricultural research, particularly assessing different management practices, field management practices, using emerging technologies, primarily drones and small sensors, but other technologies as well. All to collect data and think about data that's relevant for climate action, and particularly climate mitigation is where I focus most of my work. I think it's really important to also say that I think about this both from an optimistic and a critical standpoint, and I think that's sort of really important when we think about both action, both in terms of technology and policy, is how to also think a little critically as well. So for me, agricultural systems, this is maybe not particularly new to folks who work in agriculture, but I think about it in kind of three components. The first being ag systems are critical to feeding a growing population with, sort of commonly cited things like, we need to close a food gap, we need to increase food production to feed a growing population. So sort of production. The second dimension is that agricultural systems are vulnerable to a changing climate. In red here are areas of the world that are projected to have, pretty huge yield decreases due to changing climate. So we think about vulnerability of ag systems, we also think about adaptation. And then the third dimension is mitigation, because agricultural systems also negatively impact the environment in a variety of ways, contributing to climate change, biodiversity loss, alterations of geochemical flows. This is just a little graph showing sort of agricultural contributions to sort of pushing on these planetary boundaries. This is just another framework that I think a lot about in my research. So with this idea of sort of production, adaptation, and mitigation as kind of the three ways that I kind of dimensions, I guess, that I think about agricultural systems, I think it can be kind of easy to say in my own work, how can data and technology support increased production without degrading ecosystems is sort of a lot of the ways that this gets boiled down to when we think about, how can we use technology and data here. But I do want to take a minute, and I think this is really important. This is where the critical piece comes in, to actually take a minute to think about how all of these systems, both our food system, our technologies, our data, are really shaped by historical and ongoing systems like colonization and capitalist systems that are often focused on, or can be often focused on, domination and extraction. And that these might seem like big words and not, and kind of thrown in here, but I think it's actually incredibly important to sort of take a minute to really dig into this and sit with this for a second. Because when we talk about policy and technology, I think we really do need to be really mindful of the social context, and especially when we talk about even from the local to especially the global sort of context. It's important to see how we can shift and deepen questions and sort of direct energies to the goals that we really want to see, and to be a little bit more critical. So just to quickly say, so for example, with production, questions we could ask are, do we need more agricultural production, or maybe we need more support for diverse and plural ways of growing and distributing food? We know ag systems vulnerable to changing climates, but who actually is vulnerable? And then in contrast, who is providing the solutions, and what forces and systems are these potential, air quote, solutions serving, is, I think, a really important question. And then when we think about the environment, what are the primary goals when we think about sort of environmental goals, or is it production? And how do we want the actions of feeding ourselves interacting with the rest of the planet and ecosystems? And also throughout all of this, like, who is we and who gets to determine these questions? And I just think this is just sort of really important to, like I said, kind of shift and deepen questions. So when we look back at this one question again, we can now kind of shift it slightly, maybe take away some of these components and deepen it and get a maybe really complex question of, can data and technology equitably support well-being and flourishing in agriculture and other ecosystems, and then also support the system changes that might be needed to do so? It's a tangle, and it definitely, for me, opens up an important context, because I think now if we sort of broaden, shift, and deepen this question in this way, I think that there's still this really rich way that technology and data can help support, answering questions like these. So with that context, when I do my research, I think a lot in agriculture about food, and this is more the production and that adaptation dimension that we mentioned. Food and livelihood security, the idea of increasing or maintaining yields, improving adaptability, nutrition, etc. So that's more of the production and adaptation. But then when I think about other systems like water systems, terrestrial systems, climate systems, and how agriculture interacts with those, I think a lot about sort of the mitigation component. So how do we reduce agricultural's negative impacts on, and Todd set me up really well with the water, particularly the water quality, the eutrophication of water bodies, as well as overuse of water, and terrestrial things like biodiversity loss, and then more relevant to how Bill and Brian set up this thing, climate and climate mitigation and carbon sequestration and greenhouse gas emissions are all sort of like how we mitigate negative impacts or promote positive ones. And this relates directly to actually four, at least, of the Sustainable Development Goals that are sort of these goals that the UN has put forward as, what we want to be addressing. And on the high level, we have like zero hunger and climate action, but each of these goals do have specific targets underneath them, as Bill mentioned, and then indicators that can help contribute to like, how are we, measuring progress towards these goals. So we're going to get into it a little bit. But on my own sort of like field research level, I do a lot of data collection around all of these systems. We do sort of like vegetation data collection, water quality data collection, terrestrial systems, biodiversity, and then my main focus has been climate and greenhouse gas emissions from soils. So these are, you know, little snippets of work that I've done, but within my own research, and certainly, you know, in the vein of sort of accelerating technological change, we've been sort of pushing on the boundaries of using new and emerging technologies for a lot of these similar data collections, either in tandem or thinking about how to either augment the data we already have or potentially replace or expand the data. So a lot of, like I said, my work was really focused on drones and small sensors and how can we use these to augment the data that we're collecting on these systems. And many of the new and emerging technologies that address, they're all addressing maybe different areas of agricultural data collection. So for example, drones can be flown to collect yield information, you know, related to imagery, but also at the same time, that same data can be really useful for actually giving us information about climate mitigation. And you know what Todd sort of mentioned, this idea of multiple environmental benefits can is really, I think, really critical when we think about these new and emerging technologies. Can be either the same technology can be collecting different data to address different goals like production, but also like water quality and climate action, or the data that's being generated for one purpose is actually the same data or can be really useful for multiple purposes. So, and yet, as is maybe not a huge surprise to ESIP members here, increasing data streams are being generated, and yet they haven't not necessarily designed for sort of semantically linking data in a machine readable way. So the sort of unlocking of the potential of using these data for multiple purposes is maybe not always there. So I just wanted to highlight a little bit some of my work with drones, for example, is that there's different data streams sort of coming out of a drone platform. We can have different sensors hooked up here. So we have an atmospheric sensor that's giving us sort of a CSV file of different data. We also have cameras that are giving us a variety of imagery data sets, and all of these could be, you know, potentially useful, and yet right now there isn't a whole lot of sort of standardization about how data is described, the sort of formats that it arrives in. So not only like integrating between these data to answer one research question is difficult, but then especially if you're having these data, they might be useful for, you know, to answer multiple questions, or different researchers in different fields might be able to use them. That's still sort of a missing link. So this is work that we've actually been doing really, trying to really focus on within the ESIP drone cluster, and we've created this minimum information framework for collection of earth and environmental science data with drones to try to say, okay, if we're gonna, you know, fly drones for data collection, how should we describe the data that's coming off of the drones such that if I fly for agricultural production, but somebody might want to use that to answer questions about carbon sequestration, it's at least findable, you know, that's a possible link. And I know I'm at 12 minutes, but I do want to quickly, so maybe try to do this quickly, bring it to the semantic linking, because I think that's a lot of actually what I've seen at ESIP has been really a lot of really awesome movement in that direction. And no matter what the technology and the data streams coming off of it, if you're linking it, sort of tagging it with this data is about, and using an ontology term, that can be really a useful way to use, you know, data across multiple purposes. So I just wanted to give a quick example about the data that I collect and the ways that I was sort of like starting to think about this, particularly with Pierre Luigi, is, you know, I think about the fertilizer and the manure that are going on the field. There's nutrients here. So on the right is sort of an example of an ontology term that could be useful within this. So as we think about just like how might we start to think about ways of linking these data? I think about nutrient uptake of the plants, but then also, of course, as I mentioned, in the sort of environmental degradation vein, I think about mitigating these effects, such as surface runoff, leaching to groundwater, the carbon sequestration and greenhouse gas emissions, and all of these terms that you're kind of seeing on the right to kind of that could potentially describe the data that we're collecting here are from either ENVO or agro, but they're all linked in a way that I'll explain in a second. Because when we think about that local field level, again, kind of bringing it back up to the sustainable development goals level, is that these data can be used both to answer, questions on the farm level, on the, regional scale, and then if we're trying to contribute to these global goals of climate action and hunger, these data that are even being collected on the field scale can be really useful. And so this was something, again, work with Pierluigi, sort of thinking about how these sort of linking the local terms linked to international terms and interfacing between these different levels of knowledge. So using sort of linked interoperable ontologies to try to describe data that might be useful in these ways. Okay, so Dan said never, in our little practice talk, never show this giant tank, like spaghetti graph of, linkings, and here I am doing exactly that, but I don't want you to actually think about it, just to think about this as like, I'm leaving you with a little taste of the kind of ways that we're, exploring how to do this kind of linking. And I'm going to get rid of all of it just so that you can see, zoom in on one part of it. That was really just the technologies that are collecting the data on the field, like buoys, field workers, and drones that we care about, can be linked through things like TMDL measurement processes, which is total maximum daily load. This is in particular situated in the water quality context in Vermont, which is, our major way that our agricultural practices have been shaped is in policy related to water quality via the Clean Water Act. So we have these data, they're being collected on the field. We can kind of scale that up to how they're related to the Vermont water quality sort of level, national level, but then this can then all the way be scaled up to things like Sustainable Development Goal 15, Target 15.1, which has the indicator for sites of freshwater and protected sort of water quality, which is just a way, to kind of just demonstrate a quick way that we were thinking about how to follow the process from the field to the global level and how we can potentially use semantically linked data to do so. So just to leave us with some challenges to us all, when we think about new technologies for data collection, we know that these data can be useful for multi-purposes, and also we know that as Steele mentioned, farm data is messy, but also farm research data is really messy at this. So yeah, so how can we think about new technologies and data collection methods that can help us sort of unlock the knowledge that we're looking for, and then also the scaling of goals. So linking these sort of field level data collections all the way to subnational to international scales. And then again, I think important to bring it back to like also a critical reflection of the information ecosystems themselves and how things should be participatory, community driven, and really critically aware of the non-neutral context that we're all working within. And so with that, I will finish and also call out to the Research Data Alliance group, the Sustainable Data for Sustainable Development Goals, which is another working group that I've been a part of since, creation years ago.
Thanks, Bob. Yeah, really interesting stuff. I think we need to talk afterwards. There's a lot of overlap with what we're interested in as far as the cluster. We are running a bit late, but if anybody has a quick question, we can do that before we go off into the breakouts.
Hey, Lindsay, this is Todd. That was a great presentation. I've talked to a woman named Diana McKnight out at University of Colorado. I like the fact that we're coming around to collecting data again. We're not just modeling our way out of all of our things, and we need more of that. I think one challenge that you didn't address, and I don't know how to address it, is agencies are becoming more and more restrictive in the type of data that they will allow to be used in, say, a TMDL. And so how we bring in these new data streams and convince our state and federal agencies to accept those data as being relevant to, say, calibrating a model or whatever it's going to be. That I think that's something that hopefully we can all help address.
Definitely. And it's like a great point, and actually something that I've seen being tackled, I think, pretty well in more the atmospheric science section of like a lot of the work that I've done with folks that use drones for atmospheric science research has been actually like, how can we make these systems like trustworthy enough to actually like help generate data that can be like integrated into weather models and things. And so that's just one quick comment. Definitely needs to be further worked on.
Right, because I think you're exactly right. We have like increasing data streams that are coming online, but at the same time, the things that have been traditionally there are going away. The USGS gauges, those types of things are going away. And so how we transition from the things that people are used to the new things is going to be, it's going to be exciting, but it's going to be a challenge too.
Yeah, definitely.
Possibly a question for both of you then, and this is actually related to some of the work that Martha's still on. Yep, Martha Apple up in Montana Tech, and some of us are doing in the virus sensor group is, can we as a data group start to figure out when is lots of data start equaling high quality data. And so basically lots of not that great of data, but you have a crap load of different sensors. That actually starts taking the place of the quality data from a $45,000 Campbell Scientific station, of which you can only afford one. Do you go for 4,000 sensors, or do you go for $45,000 sensor?
Right.
That's a great question, Dan. Of course, that we all accept remotely sensed data from satellites, which has these huge footprints of very coarse data, and even the SMAP satellite, the thing that's supposed to be measuring soil moisture, which is really giving crappy data, but we're getting a lot of it. I think there, and we start to ask this question: is it good to have a lot of information, even if it's at low precision, versus? And I don't know the answer to that. I think we kind of need a combination of these two things. But I think what we don't want is to put all of our money into 4 measurements that are super precise, as opposed to.
I agree. Yeah. I think it depends a lot on the range of what variables you're looking at and what your questions are. If you can have something that's a little imprecise but inexpensive and get more points, if that's applicable to your question and you've got it in a tolerable range, that's probably okay. But if you need something super precise, that's, for a different question. But I think it's one of those things that doesn't have one answer.
Yeah, but then once again, Martha, you have a lot of nice new data for much less than a $45,000 Campbell Scientific station.
Indeed.
So, and in places where you would not be able to put one of those stations.
I'd be able to put it, but it would be quickly lost on the alpine tundra. Yeah.
Very good. We wish we have time to continue this conversation. To Brian, we probably will have fewer minutes than we had originally planned for the breakouts, but if you could just show that final concept map and then give the instruction to everybody before we break out.
Sure. You probably see my screen right now, so I'm not going to spend too much time, but so this is the concept map that was evolved as the talk progressed. And what I have done in the last few 2 minutes was to replicate this emergent map that captures ideas from the different speakers. So the ideas from the different speakers are colored differently. I won't go through who's what. You can probably figure out from the different colors who said what. But they have been captured in these breakout group sketch documents that are linked to in the session notes. There are 6 break out, there are 6 documents. And so what Susan will help us do next is to break us all up into 6 different groups. Once you get into your breakout group, depending on which breakout group you want, to pick your document. And there are 4 questions on the right-hand side. Again, for lack of time, I wouldn't read out the questions to you, but pick one question to work on maybe. And you have also the option of annotating the image, as you see here on the screen. You will actually need to zoom in by just hitting the zoom operation on the sketch, on this sketch program. And so we will see you back here, I guess, I don't know, when, Bill?
I have 5:15. I figure we'll come back at 5:45, so 10 minutes.
But do we end formally the session at 5?
5:15, so we'll be back at 5:25.
Okay, got it.
So 5 minutes at the end to wrap up.
Okay.
I will bring you back at 5:25. I put you into 3 rooms so that we can have a decent number of people in each room. So I will send you off now.
Thank you. That was a quick 10 minutes.
Yeah, sorry.
I hated pressing that button to bring y'all back because I knew you were probably just getting to the meat of it.
Yeah, true.
So we got 5 minutes. How many groups did we end up with?
You had 3. You ended up having 3 groups.
3.
As people dropped off, I kept combining them for you.
Okay. Okay, so maybe the 3 groups can just take a minute each and kind of whatever they come out with.
So Bill, I'll go ahead. I think one of the things that we discussed was the concept map that we generated kind of on the fly. So Jonathan rightfully remarked that a lot of the concepts there are too complicated to be squished into one node. I mean, things like, so I think we were talking specifically about Lindsay's mention about colonial systems. And so that's a very complex concept. And so I don't know, this is a question, Bill, you and I have been talking for some time, but whether it merits sessions organized around decomposing those concepts, so that we can have some way of putting some borders around it. And I think that's I don't know whether the group that I was with, whether you guys have any other additional thoughts.
Brian, do you mind if I ask you a question related to what you were just mentioning?
Sure.
To what your group had mentioned, that it's hard to bind them all into one. Though I'm going to actually give a quick question as to why was I able to read the map that Lindsay put up in when she actually put up one. I was able to understand that one completely, really quickly, even though it had more information than someone, I forget who, said that should be on one page. And I understood that one, whereas we were having difficulties with the one that we were just presented with. How do we close that so that the one that we were just presented with looks like bars?
I don't think there is a solution to that. Again, because it's just different layers of abstraction given the amount of space that we have, and as humans, you think very different from everybody else on the screen here. I just think it's something we need to accept given a restricted amount of time and space. That's all we can do.
I bet there's research though about how people in general will like move between different concepts on a concept map, or like what words would bring people in, maybe. I don't know.
I mean, I'll speak up and share to that, I wasn't necessarily connecting to a lot of the things that were being said. And I looked at Bar's map and I saw TMDL. And as Susan Minnemeyer knows, in the Chesapeake watershed, I saw TMDL, my eyes went right to that. I perked up, I was like, oh yeah, I'm in. So, I think different people connect to different things in different ways. I think you got to try out, sometimes a really detailed map and then sometimes a more generalized, and you'll hit your audience, one way or another.
And one thing that we wanted to experiment with, so Bill and I have floated this before the Forest Service folks, is that, one possibility is to express your thoughts in terms of a concept map, submit a concept map to a machine, and the machine actually retrieves a similar concept map that has parts of your concept map. That's something that we've been kind of probing around on the edge. So it's a way to ask the machine a question using a diagram and to get back an answer in some sort of a diagram.
Maybe that's one thing for the upcoming, this rest of the year for the cluster, or right, this aspect of the abstraction of the nodes of the concepts. Let's see. Oh, I see 5:30 already. The second group. Do you have any quick report outs that you want to share with everybody?
We just got to the first question, the how do you envision this map could be useful for your work? And we talked about how it could be useful for communication between agencies, as well as between potentially with at least practitioners. Also helping researchers identify where their work could receive potential funding, as well as helping new faculty, particularly define research teams, or maybe find new people that they need to add to their research teams. And then also help with specific identification of specific data needs.
Okay. Yeah, all good stuff. Anybody else in the group? In that group, any other comments? Okay. So in our group, hey Bob, do you want to just summarize the discussion we had about the different abstraction and how it might contribute to SDG?
Yeah, I was just, I don't know if this is a fair summary, but one of the points that I was making at the end is that Bill had asked a question like, do you think that if we could trace, stuff from like data that's collected on the field level to the sustainable development goals level, would that be potentially useful in terms, correct me if I'm wrong, but the idea being like, is that a potentially useful thing for, addressing in particular sustainable development goal or target? And I think some of the work that we're doing in the Research Data Alliance data for SDGs working group is actually working with folks like one of the chief statistics officers that's really instrumental in sort of amassing the data for the sustainable development goals, or at least has a finger on the pulse of that, and other folks who are really high up and think a lot about data collection for sustainable development goals. So I think maybe there could be a cool cross, like if we could tap into the knowledge, sort of the knowledge base of the RDA SDGs, which Bill and Ryan, you guys have joined our one of our calls before. Maybe there's some cool overlap, so that could be a useful, thing, a goal potentially with input from professionals that know a little bit more about the data that's being collected for SDGs, and how demonstrating this sort of linking could be a useful template potentially.
Yeah, I definitely agree. I think that's the connection between our cluster and then your recently formed RDA SDG group. So we definitely want to explore that, and specifically with regard to this different levels of abstraction, and then from the local on the ground to the global, and then how that kind of mapping can contribute to the SDG. The metrics.
And there's work going on with the Discovery cluster. Chris Linus is trying to do a lot of that same linking between data and how the data is used. So and you know, so this has been going on, and Jonathan has been in that Jonathan Blythe has been in that conversation also about how do you, I mean, so this is definitely a cross cluster activity. It's beginning to sound a lot like a cross cluster activity. Chris Linus has spoken quite a bit about that, and I know people around the room, Lindsay, yourself, Jonathan is so interested in that. So yeah.
Okay. Yeah, I
We'll
want to
follow
respect.
up. I was just gonna say that, Brian, hopefully we can follow up and finish our conversation at a coffee break or something. There was not enough time for breakouts. We have a lot to discuss.
There isn't a formal coffee break scheduled tomorrow, but the coffee break space is always open. So you should be able to go to it. And I will double check that it'll be on the Kiko chat space tomorrow, but I'm happy to make that available for any of you so that you can continue that conversation.
Well, I'll find you, Brian, one way or another.
I know you will. I wanted to encourage you guys that there is one more late night session tonight for those of you who can, keep going. We do at 6 o'clock have one lone session on credit for research artifacts. So if you've still got a little bit of space in the tank for a little more, I know that team is pretty passionate and we'd love to have you there. So otherwise we will see you tomorrow. Thank you all for being here.
Yes, and thank you again to the speakers, Todd, Steele, and Lindsay. Very, very interesting talks. We definitely will be following up with during this session. Thanks again, everybody. Appreciate it.
Excellent. Thank you.
Thanks a lot.
Thank you. Bye-bye.